DAT is a data architecture modeling tool for IoT application that describe how data flows through the system from the generation to the data consumption. It has the ability to provide two levels of data architecture, high-level architecture and low-level architecture. The description include data format, data processing type, storage analysis type, and a way to consume the data. The idea from that is to provide a data architecture tool that makes decision based on data easier and accurate. For IoT application, we have different data sources and the data in different formats. We need to make sure that the data will be transformed to unified formats. Moreover, the data is generated at a different speed that need to handle the scalability and reliability of the provided data architecture. In general, that gives the ability to describe data to make sure that the data will be transformed into a valuable data. In our previous work, we developed a CAPS, an architecture-driven modeling tool for the development of situation-aware cyber-physical system. CAPS focus on three views: software, hardware, and physical space. CAPS and DATS are built on the conceptual foundation of IEEE 42010 that focus on the data view to give the stakeholders like data architect, data science, and data engineer the ability to describe the data flow. That is built on meta model that define the modeling language in which the model can be described. Our data modeling conform to the meta model. We used Eclipse modeling framework which contain EMF core that include a meta model for describing the model, GMF framework that provides a generative component and runtime infrastructure for developing graphical editor based on EMF. Eugenia is a tool that simplifies the development of GMF-based graphical model editor. An interface for that we have on the left side a model, so we can create a new model. In the middle, the graphical editor. On the right side, we have the palette, which contain object and connection. Object in the above, which contains all elements that we need to describe the data, and in the bottom, the links to show the direction of the data flow between elements, the order of the data. These kind of three links as follow: link between data nodes, between data elements and data ports, and send receive element. And we have in the bottom properties to edit, add data about or information about elements, and link like name, type, and other use for information. As a result of our tool, we have the following simple example model. The first three elements in the left side are IoT devices as a source of the data. Then the ingestion phase that collect data from the sources and store it in the data lake as the raw data. Then processing phase, which contain real-time and batch processing to convert the data to another form to be ready for another use. For the evaluation, we have 5 real cases evaluated, 4 cases done by 7 industry professionals from 2 different companies of different domains and researcher to check the expressiveness, and the last case done by 18 students to check ease of use. As a conclusion, that is an architecture description and association modeling platform for data architecture for IoT application. It is implemented on top of Eclipse modeling framework. As a future work, we are trying to finish the evaluation with other companies and integrate with other existing technology and tool. And thanks.